Hello, everyone. Welcome to the first webinar hosted by Japan Technologies. Just to remind you, the Japan Technologies is one of the 8 companies brands that make up the KPM Analytics holding group. So the main aim of this webinar series is to share with millers and bakers and in general with all people who are involved in the grain industry sector the certain keys, knowledge, and different experience when thinking and talking about the quality control by working with the flour and dough. Before getting to the heart of the matter, I will give you some practical information about this webinar. First of all, my name is Hanna Zhugunova, and I'm a food application specialist in Japan Technologies. And today, on behalf of the entire Japan team, I will be your speaker. Today, we'll talk about the challenges of the water absorption control. Why controlling the water absorption capacity is important and how it affects raw material and final products. How flour constituents like fiber, starch, and protein content can influence the water absorption capacity. How to apply technologies to have balanced flour water absorption rates and rheological properties to produce your best possible product. This presentation will last around 30-40 minutes, after which I will try to answer to all your questions. You can ask your questions during the presentation, thanks to their Zoom question and answers feature. So if I don't have enough time to answer to your questions, me or my colleagues will contact you by email at the address that you're actually providing during the registration. And the one final point, this webinar will be recorded. So you will soon receive a link to access to today's recording. So you can revisit any main stories points in more detail. Okay, so let's start. We're starting with a small reminder from farm to fork. Farm to fork, this is the strategy aiming to make a food system fair, healthy, and environmental friendly. So what actually the process to bake a bread? First of all, we needed to sow the seed. After, we need to reap the harvest. After, we need to proceed this way in order to get the flour. After the flour is obtained, we go into the bread production to get the dough and to create the final product that is called bread or other different materials. So the final product is very important. We are creating it to make their satisfaction to the customer. And all this part of the process will have a great impact, starting from the entire raw materials, machines, operators, methods, and concluding by metrics. So the basics. Have you even done bread in your kitchen? So we're talking about that. So what is the first major ingredient to make a bread? Flour. And for example, we were doing our bread in the kitchen. Where are we getting the flour? Yes, of course, we're going to their supermarket, but actually the process is much more complicated. It's not so simple as we think, because the grain needs to be milled, and milling is going into the big industrial process that will have actually the great impact on the final quality of the flours. But we're not eating flour. We need to make a dough. And to make a dough, what we're using just flour and water. But what happens if you add less water? If you don't add enough water, the easier will be, of course, easier to manipulate, but it's not stretchy enough. It's dry, it's stiff, it proves slower, it has an influence on the under fermentation. It cannot occur final development. So these kind of the problems will also relate on the final product, that will have the staling much more quickly, will have low volume, will have dense really and firm internal structure of the crown, and in the end, we will have the white corner edges. Okay. And after we're going to there, what happens if you add more water? If you actually add in too much water, the dough sticks to your hand and it quickly gets everywhere. So it's wet, it's sticky, over fermented, it's hard to handle the process, extended cleanup time. But can you imagine if we were talking about our kitchen, what can happen during the production? So this will influence also the final product. We'll have the poor symmetry, we'll have very large volume, but actually we'll have open crumb grain with the very large cells, and the final product will be much more disposed to mold. So we can see there is overabsorption and underabsorption has a very great impact on the final products. So the question is how to find the balance. But before going to that, we need to understand what we'll tell from the economical point of view. Economic point of view is that the more flour absorbs water, the greater the financial benefits are. I will try to give you an example. There is an example, we have industrial bakery that is producing 1,300 bread per hour. So we have around 3 million per year, selling price 70 cents. We have quantity of flour purchased per year with a 616,000, average price around €1. And we have the quantity of water used per year, that base, for example, 60% water absorption. And the price will be around €0.035 per liter. So for us, if flour is absorbing more, it's okay. If the flour is absorbing more, we're going to produce more dough. So we'll be producing more bread, and finally we'll be selling more bread and cost of water. Production cost in terms of water will be increasingly very little because water is not expensive, as we can see. But we are going to sell more bread and cost of water that will actually going to increase this margin. But here, there is a tricky, so we need to pay attention, because if the bakers will add too much water, we can have the potential problems and potential higher production costs that will be expected. So there is real need to find this balance between quantity of water and the flour. Kitchen. How do you know that your dough is good enough? So what we are doing? We are checking its consistency. Is it stiff? Is it soft? Or is it sticky? And to talk about the consistency, we're going to understand how it's important. Third thing, this is dough consistency and quality of ingredients are very crucial to baking. And the consistency, this is the key in baking. At the artisanal baking level, we have some kind of the consequences. For example, one can add more flour if the dough is too soft. Another one can add more water to a dough that is too firm to achieve this ideal consistency. However, these issues are easily resolved in our kitchens, putting more flour or less water, etc. But for a high volume baking operations, during industrial baking level, this is not so simple to make this kind of adjustments that can cause potential costly production issues. So in practice, the industrials, they need to have the flour with the optimal and very consistent water absorption. And it's very important. So when we talk about the water absorption, we need to go into the reason to understand what is that exactly. Water absorption, this is the capacity of flour to absorb water in order to achieve this desired consistency and to create quality final products. What happens? So first of all, when we're adding water, we have this kind of the competition between the constituents of the compounds of the flour to absorb the liquid. We have damaged starch that will be the winner in the game, and then will attract the water more quickly than protein. Then after we have damaged starch that doesn't know how to retain water, and the water will be released. So etc. etc. So we'll have this kind of competition. After we have the gluten forming, so development of the dough, water hydrate the gluten forming proteins and other ingredients. And in the final, we get our first material that called dough. So when we have this consistent texture. In the final, this will relate and influence the final product, especially the texture, the volume, color, and also other parameters. So the thing is how the dough is controlled in production. And actually, this is by touching with our fingers. By touching with our fingers, we can see its consistency. So this is the manual physical control. But the manual physical control has their limits, and we're looking for it. So first of all, do it depend on the person? Yes. For one operator, it can be good, for another not. So how to find this real balance, how to find who had the right? The second one, this is precise. It's not precise because, as we said, it's dependent on the operator. That's why it's subjective, because this is the sensory evaluation where the person doing the test also judge his work. That's why also we have the thing that it's very limited understanding. Okay, so we see that the dough is sticky or dough is giving this, that, but actually it will give us this only this information, but it will not give on which reason, what is the reason behind that. So what to do then? What are the alternative solutions? And the solution, there is analytical tools to control water absorption. There is a lot of companies that propose analytical instruments like Mixolab, Farinograph, Dolab, and others. And what this equipment will do, they will analytically determine the quantity of water that needed to get certain consistency. How they will do that? They will fixing their target desired consistency. The quantity of the water will also influence on dough behavior further. So the question will ask, is that enough? Is it enough to do that? And does the process really stops after mixing, after getting right water absorption? The answer is no, because we solve only the first part of the problem. Why? But because we have, we get this information about the water quantity that we need to achieve certain consistency. But after we have these different questions, what about the tenacity of the dough? Is the dough elastic? Is it possible to stretch the dough? Is the dough extensible? Is the dough porous? The dough sticky? And we have an answer that, of course, we are not stopping on the mixing. And mixing, it's not the last stage in the baking. We have different these parameters that will influence on our dough. So looking closer, what do we have? Two flour with the same water absorption. So you can see in this graph, we can present it water absorption of the flour A and B. It's almost similar, 60.7, 60.8. But we have different composition of the proteins, of the starch damage, of the ash, and consequently, this all will influence on their dough during mixing, meshing, and baking. So what the reason, how the different components of the flour absorb water? Okay, so let's look on it. We have the water absorption rates that we cannot view independently on the viscoelastic characteristic of the dough. We have three main components of the flour. This is protein, for example, first one, this protein gluten. So protein gluten absorb around 7 and 70% of the water. So as more we will have protein and gluten, the more the water absorption will be. And this will influence on the viscoelastic glutening that will influence on the dough elasticity and extensibility. After we have the pentagons that can absorb up to 15 times their weight in water. So this is water holding pentagon that markedly increase dough viscosity. And we have starch. We have native starch that will absorb in 0.3 times its weight in water. And we have the damaged starch that will absorb in 3 times its weight in water and will influence on its thickness. So we have these all components that are very important. Reach this balance between them. We are proposing the solution with analytical analyzers. As we saw that the making bread is a very complex process, we can control each constituent but by our solutions. By NIR, by Alveolab, by Mixolab, by enzymatic, and by SRC. We're looking in details further. As we saw already that, okay, we have this kind of flour constituents like protein, gluten, pentagons, and starch. Why just not to find their quantity? And that's it. We have the SpectraStar for that. This is near-infrared spectroscopy technology. This is used as a rapid and non-destructive technique to measure many wheat quality parameters, like such protein, starch, fibers, moisture content. Okay, but however, the quantity is not quality. Why? Because these methods lack the ability to explain the behavior of the dough. We have this is only quantitative parameters. So we have this kind of the parameters that's contributing during the process, but it's not telling about the processing, it's not telling about the finished products. We have this kind of the prediction. So this is not enough. But we have the rheological devices that will help it. And for example, first of all, this is focusing on water absorption and protein quality with alveolograph. What is that alveolograph? This is actually the equipment that measures water absorption characteristics of the dough, such as tenacity, extensibility, and elasticity. Alveolab, this is the equipment that will help us to analyze this kind of characteristics. So tenacity, for example, when the baker will be touching by the fingers to see the capacity to resist deformation, the baking strength, elasticity, when the baker will release the dough to see this resistance to deformation. We have extensibility, so when the baker will stretch the dough to its maximum. So all these characteristics can be analyzed by Alveolab. Okay, go further. We'll be talking about the baking process. And to analyze and to fix your water absorption and baking and to see prediction of the baking process will help the Mixolab with that. So this is the perfect tool to measure the water absorption and the characteristic of the dough, such as protein behavior, starch behavior, fibers behavior, and different interactions. And it will give you not only information on water absorption, but it will also give you about the behavior of the dough, about the volume, structure, color, and especially preservation. So by Mixolab, you can predict your process to see how you go further with it. After we'll have their starch damage that we'll analyze with enzymatic. Enzymatic, this is equipment that will give you an accurate measurement of the amount of damaged starch in the flour. Okay, so first of all, this starch, damaged starch, actually, this is the typical error of the miller, because it's depending how many reductions stages he had, depending what is the extraction rate and everything. So by rolling between the blades, we destroy the starch. And actually, the baker will have the problems because of that. We'll have, for example, the sticky dough, inconsistent shape, inconsistent proofing, inconsistent volume size, overproofing, poor shelf life, cracked products. All these issues can be related to the starch damage. And this, of course, can be measured by enzymatic and will help to understand it. Going further to understand their constituents that absorb more or less. So we saw different constituents. We understand, okay, the quantity and everything, but each constituent absorbs differently, depending on the flour type also. And how to understand from where the water absorption is coming, it's coming more from the protein, or it's coming from more from the fibers, or from damaged starch. This is the SRC Chopin 2 will help with that. For example, we want to get a bread, and to bread we need to, for example, to this kind of bread, we'll need to have high gluten, we need to have the less damaged starch, more pentagons, and all the specification can be created for each product that desired by you. So it can be crackers, it can be cookies or cakes. So you can really understand from where the absorption is coming for and make specification for your product. So we have a range of products to help you mastering your production. And this is the equipment that will help you to understand your water absorption, the stickiness, the dough consistency, the extensibility, the elasticity, all these kind of parameters. Okay, so we're going to the process and formulation, and we'll talk how our solutions can help with that. So first of all, what is the relation between ingredients and consistency? For some certain products, we need to add ingredients. We saw in the beginning simple recipe when we just need to have water and flour to make a dough. But if we add, for example, fat, different yeast, salt, actually that is coming in the real industrial production, will have different impact. And all this impact will have this kind of influence. We'll have this strong relation between water absorption and the consistency. And for the certain products, we will add ingredients for certain not. So this will influence on the consequences of the final process and also on the final product. Okay, so I will give you an example about how water absorption varies depending on the formulation. Actually, the addition of different additives have different and great influence on water absorption characteristics of the dough. For example, we have an example of the flour that have the same water absorption but different addition of sugar or fat. And there is a graphic that you can see. For example, if we're talking about the butter, flour plus 0% of the butter. It's a blue graph, flour with 1% of the butter, the orange, and flour plus 2% of the butter. We can see the different behavior during the process. So in the end, it will be, of course, the different product, but this actually be one water absorption, the same. And the same effect we'll have with the sugar. So that means that you can have the kind of the prediction of the impact of the ingredients thanks to the mix lab. So if you add much more butter or if you add much more sugar, what you will have in the end, how the process will be going, if your dough will be stick or not. So this will tell everything about, our Excel will tell about that. So we'll go further talking about their finished products. Actually, different bakers has different target consistency. It will be not the same. It will depend on the baker that the baker will be looking for and actually on the final product that the baker is searching. For example, if we talk about the bread producer will be seeking a maximum water absorption to increase the yield to get the product, we call standard dough. The biscuit producer will seek for a minimal water absorption to get limit cooking cost. The consistency will be like a crumble. And the third one, for example, the baker of the cake and pancakes producers will seek for the liquid formulation. So we see in this example that we have different target consistency, and depending on that process and that product that you want to see, you will make some adaptations. The dough properties change depending on the process. We have an example. So actually, we need to understand and control dough consistency throughout the process, because as we saw already, this is really important, and this is the main key to maintain consistent product quality. For example, we have line A and line B. This is actually two different lines. They have different machining on it. But in the end, we need to have the final product. What we will do? Of course, if we will put the same flour and following all steps of the process, the final product will be not the same, because this is actually different lines. We have different machining that are behaving differently. So we need to adapt our water absorption. For example, here we are adapting water absorption because we need to get the same product in the end. So the thing is, you actually, the baker, you need to analyze your process. You need to understand what is good for you, and by using the analytical equipment actually. And one time you do it, you'll find that actually to get only this water absorption, it will be not sufficient to you. It will be not enough, because we'll have other process that is coming after the dough development process. And that's why we can help you. And it's going to the conclude. We're telling about that we have different kind of the issues during the production that we are struggling every day. And all these key issues can be related because of the water absorption. We have the under absorption, over absorption. So we'll have the kind of technological problems for production. But only to measure the water absorption, it will only have this effect on the behavior of the dough and the final products. So we need to see other solutions that will be adapted for that. And we have these solutions that will be at your disposal. We have NIR and alpha moisture compositional analysis for various industries. We have our functional and neurological analysis for grain, flour, and dough to understand what is after. And also we have the machine vision inspection for food production and packaging lines, when you can analyze your product, accept or reject in line. I hope I was clear. I would like to thank you for your attention. Just one moment. So you can ask your questions by using the question and answer section during the presentation. Or if you don't have the question today, of course, you can contact us at sales.analytics.com, and we will be happy to answer to your questions. Thank you again. So I will go to the question and answers folder to see if we have already the questions. Okay, so we have one question that is, we're talking about starch damage. Starch damage, what is typical usual level of starch damage expected in bread flour? What range variance would be needed to integrate challenges in the bakery? How much does starch damage vary day to day, week to week, from flour to meal? Starch damage, this is actually a parameter that I said you that this is the miller are creating for. For example, if you want to miller that want to have the high extraction rate, he'll be passing 2 or 3 more times during their reduction system, and during the rolls will have this kind of destruction. The starch damage can depend on the flour, so we cannot tell you what is the level normal, what is level not normal. By analyzing on the equipment, you are finding your proper level, because you're going from the final product. For example, it depends on the final product. If you want to make a bread, so you're analyzing the starch damage that will be good for your bread, and after, okay, you're making your specifications. It's not we that we're creating the specification. For example, if I will tell you around 80%, for example, it's good for France, but it will be not good for the Eastern Europe or for the America. So this is depend really your process, what you want to achieve. For example, if you're a miller, for which bakery you will send your flour. So you need to have this strong communication, actually also millers and bakers, in order to create your own specifications. There is a question from the Miguel, how much would an alveolar be? Please contact us at sales.com and we'll be answering on this question, okay? Thank you, Casey Lowe, for telling that it's a great presentation. So your question is, are any of the analytical devices that are mentioned capable of being in line to measure raw material or dough properties in real time. Actually, for now, we have their Mixolab, but this is actually, we need to have an operator. I need to check with my colleagues, but we have special that we call the dough kit that is installed in the Mixolab, and you just need to take your dough in the production and to put inside. I hope I answered your question. Another question. I'm looking for another questions. Okay, there is a question from the Lisa Godkin. What would you suggest is a significant difference in starch damage? A significant difference, you meaning by analyzing the starch damage on their two parallels, like repeatability. Repeatability actually depends on your process. We have, you can contact us and we can provide you showing the repeatability results. But the difference will depend actually on what product you want to get. Okay. We're looking for the others. Just waiting a few seconds if somebody has more questions. Not for now. Okay, there is a question from the Tracy Howard. What is the best instrument to predict water absorption for bread breaking? This Mixolab. This is their equipment that will give you the water absorption, and also will tell not only about the water absorption, will go further and talk about your actually baking process itself. So you're taking your flour, you're putting it inside, you can analyze and to see, for example, for what you can use this flour, and all the process of the baking that will be predicting by this equipment. Okay. For more questions. Okay, there is a question from there. I'm sorry, I cannot read all your name. So how pentasons act in water absorption? As I said, with the pentasons, they can absorb around 15 times their weight in water. And actually they will, how they will absorb, they will increase the dough viscosity. So to influence actually on the viscosity of the dough. So that's important to control it. Okay, I don't have any questions. So I would like to thank you for being with us today on this webinar. We hope to see your next episode that we'll be doing next year. I will take this opportunity also to wish you a good holidays. And just one thing, if you have any questions or any information that you need, you can ask us by contacting us at sales.capeminalis.com or just by contacting one of our colleagues. Thank you again. Wish you a good day or evening, wherever you are. Goodbye.